So here we have dictionary having few words that we will be searching in the Boggle, and the size of this Boggle will be dimension 1 cross dimension 2. So it will be a 4 cross 4 matrix. Now let's create the function find words and let's pass the Boggle matrix in this function, and let's pass the visited matrix that we will be using to keep track of all the visited words, and I, j, and word. I and j are the coordinates of the character in the Boggle from where we are going to start forming the word. And this word that we are passing in this function, this will be initially an empty string, and then we will keep forming this to make a valid word using the characters that we are picking from the Boggle. So we will pick the adjacent letters from the Boggle each time and add it to the previously formed word. So let's visit the letter at IJ cell in the Boggle and join the word and Boggle and get the new word. For the first call, it is the first letter. For the first call, it will be I and J will be 0, 0. So it will be the first character present in the Boggle. So as we are visiting this word, we are marking it visited in the visited matrix. So now let's run for loops to select the adjacent characters to form the possible words in this find words function. So the loop will start from I minus 1, it will go till I plus 1 and will increment the row each time. So in row we can cover a step backward and a step forward from the current cell, right? That's why we're taking I minus 1, we're starting from I minus 1 and going till I plus 1. And now for column, in column we can move a step above the cell and a step below the current cell. So we will start from j minus 1 and we will go till j plus 1 and we'll increment the j each time. This will make all the possible combinations here, all the possible adjacent combinations. But before doing anything, we must check for the constraints, right? So let's check if it is valid to consider the respective cell or not. So here let's pass row, column and visit it. And now let's create this function is valid. So row must be within the array, column will also be within the array, and the cell must not be already taken or already visited, right? So let's check these constraints here. Let's check if row is greater than equal to 0 and row is less than the bound, which is dimension 1 for row, and same for column. It should be greater than equal to 0 and it must be smaller than dimension 2. And now the cell value visited row column, it must not be visited earlier, so it must be 0, and here we are returning it. Now coming back to find words, if it is valid then call find words further. So here comes recursion, calling find words recursively and passing the parameters Boggle and the visited matrix, row, column and the word. This word is the one that we have formed at the start of this function. And now here, let's say visited I and j equals to 0. This is the backtracking step. If the recursion is not working out going further, then we must backtrack here. So now the base case. And here, if dictionary includes this word, then we will not return anything. We will just print the result, as this function is not going to return anything. This is the base case. So when we find the word, we will print that word. So if a word is present, it will print that word, otherwise it will do nothing. So this is the Boggle we have taken. I've already copied it, so I've pasted it here. Now let's take a visited matrix to keep track of all the visited words, and now let's take for loop. I is less than dimension 1 and I++, and for column we have dimension 2. So here we will pass dimension 2 and we will fill it with 0. And now let's take for loop. I is less than dimension 1 and I++, and for column we have dimension 2. So here we will pass dimension 2 and we will fill it with 0. Now let's say I is 0. It goes till dimension 1 and I++, and now here for j is starting from 0 and j is less than dimension 2 and j++, and now let's just call find words, pass the Boggle matrix and visited matrix I comma j and empty string, which we're gonna use to form the word. And here see we are starting from 0 0, and then these for loops will cover all the cells, all the characters present in this Boggle. Now this is the implementation. Now let's run this. So here let's write node boggle.js, and this is the result. And these are the 3 words that are present in the dictionary and that can be formed from this Boggle. So if you see this Boggle, the function starts from t, which is the first character, which is present at 0 0. So it starts from t and tries to find out the word that can be formed starting from t. And it does not find anything, and it moves to the next character, which is y, and then moves to the next character, which is r, and checks for the adjacent characters and try to form a word. So it finds out that it is having a right below it, and then the recursive calls takes it further from here, and it finds out that y is present diagonally left to a. So this forms a word ray, which is present in the dictionary. So here the outer function call for r completes, and then happens the next function call for s, and this goes on to find out words starting from these characters. This is how this function or this program is going to behave.